Welcome to this short training program about chemicals in the engine room. After reminding ourselves of the risks these chemicals bring, we're going to look at one of the main ways of identifying and controlling these risks, the safety data sheet. We will then identify the procedures for safe storage and handling of chemicals in the engine room and discuss the requirements for first aid. Have you any idea how many different chemicals are used in the engine room these days? Some suppliers have over 100 different chemicals they can sell you, just for use on ships. Of course, these chemicals are very useful, but some of them are a little risky. They're a little bit risky to store, they're a little bit risky to use, and we need to be careful of how we dispose of them, because some of them can harm the environment. Of course, the problem is that on board the ship we are very busy people. We are using these chemicals every day as part of our routines. We are cleaning machinery with them, using them to treat sewage and fresh water. They can even be added to the fuel to help us burn it more easily. Sometimes we are very aware they are strong chemicals, for instance when we use them for boiler water treatment, but sometimes we forget. Here are a few examples of what can go wrong.
An engineer had been pouring chemicals from a storage container into a flask. The right precautions had been taken, and the engineer was wearing goggles and other personal protective equipment, PPE. However, when the right amount was nearly in the flask, the engineer removed his goggles to check. When the flask was put down on the bench, some liquid chemical splashed out and hit him in the eye. It only takes a moment to have an accident, so always wear the correct PPE and keep it on until the job is finished. We sometimes need to use quite powerful solvents and carbon removal chemicals in the engine room. However, these chemicals will do more than just clean and remove carbon. They can damage the skin and lead to serious skin conditions such as dermatitis. Avoid contact with chemicals. Wear rubber gloves that can resist chemicals, in addition to using barrier cream. Use a chemical-resistant apron or any other recommended extra protection. And make sure your overalls are clean. We'll be saying more about this as we go through the training.
Yes, we should all know the risks, and all chemicals should always be labelled. The labels might vary a little bit depending on where and when the chemicals were made. But in case you have any doubts, here are the common ones.
Most chemicals, to varying degrees, are poisonous, either through swallowing them or even just by skin contact. This is why they should never be put into unlabeled containers where they might be confused with food or drink. Many chemicals can cause irritation or swelling of the eyes or skin. This includes certain cleaners, fresh water and boiler treatment products. Some chemicals are strongly acidic or alkaline and can cause burns. Strong acids are often used in boiler water test kits. The rule here is to add the acid to water and never add water to strong acid. This reduces the risk of splashback and overheating. Oxidizing agents can react with other substances and other chemicals, bringing a risk of fire. Chlorine tablets used in the final stage of some sewage treatment plants and for swimming pools on passenger ships are one example of an oxidizing agent used at sea. Most boiler chemicals, chlorine tablets, and some commonly used cleaning products are harmful to the environment. This means that we have to be careful how and when we use them, and how we dispose of them or any waste that contains them. Paints and solvents are probably the most common flammable chemicals you might meet on board, but they're not the only ones. Because of their flammability and the quantities often carried on board, paints and solvents are normally stored in a paint locker where there's better fire containment and fire suppression than elsewhere. It is unlikely you will see this label on chemicals used in the engine room, and such chemicals should not be stored there. This sign for long-term risks was introduced as a new additional sign when the international labeling system was revised. Be careful. Many safety datasheets refer to there being no known risk or no data available, because there have been no proven links between a chemical and cancer or respiratory problems. However, as with other substances such as tobacco or asbestos, it may be that such links will become obvious over time. The best approach is just to avoid direct contact with chemicals. With the number of different chemicals we're likely to come across in the engine room, it isn't surprising that suppliers are obliged to provide us with a safety data sheet, SDS, which was traditionally known at sea as a material safety data sheet. The safety data sheet contains information on the potential hazards of the substance and how to work safely with it. The first section on the safety data sheet identifies the substance, its uses, and details of the company supplying it. Many authorities also require an emergency contact number for advice. Section 2 of the safety data sheet identifies the hazard, in this case the very real danger of severe burns. Section 3 gives the composition or information on ingredients. This information is particularly useful to expert emergency services when dealing with a medical or fire emergency. One look at Section 4 shows us why we need to have safety data sheets on board and be able to get hold of them quickly in an emergency. Section 4 gives advice about the first aid treatment for the casualty in the case of breathing fumes from the product, swallowing it, or getting it on our skin or in our eyes. You can imagine that if anyone was unfortunate enough to have such contact with a chemical, you wouldn't want to waste time searching for the first aid advice. So, you should always have the safety data sheets readily available. You can also see that we have advice for first aiders. In this case, we are warned about the dangers of fumes, of giving mouth-to-mouth resuscitation, and the danger of chemical burns from the casualty's clothing. Firefighting advice is given in Section 5. This is important because in some cases it may be dangerous to use water on a chemical fire. Section 6 deals with the procedures for accidental release. Since many chemicals cause damage to the environment, containing the leak and then transferring spilled chemicals into sealed containers for landing ashore as hazardous waste are often recommended. Section 7 of the safety data sheet deals with handling and storage. And Section 8 deals with exposure controls and personal protection. We'll be looking in more detail at these two areas later. So, for now, let's finish our look at the information in a safety data sheet. Sections 9 to 14 give more information about the product itself. Section 9 gives more detailed physical and chemical properties. And Section 10 is very important for storage, since it tells us how stable the chemical is and which other chemicals it will react with. Chemicals which will react with each other should never be stored together. Section 11 gives more detailed information about the toxicological or poisonous hazards of the chemical, starting with any acute effects, such as we have here, and then going on to longer-term effects. Section 12 gives the potential harm of the product to the environment. For instance, here, the risk was assessed as acute to some water species. Section 13 gives the disposal requirements, but these tend to be generalized since local legislation may vary. Sections 14 and 15 give transport and regulatory information, which is not so relevant for staff on board ship but is there for reference. There is a Section 16 for other information, which completes the safety datasheet. We do have a lot of information to take in on board ships, but we should take the time to read the safety datasheet before using any chemicals, just to remind ourselves of the dangers and make ourselves aware of the first aid actions. One good way of doing this is to brief all staff that may come into contact with it about any new or different chemical delivered to the ship. Chemicals need to be stored in a safe and secure storage area, with access limited to those trained and authorized to handle and use the chemicals. Chemical containers should be well secured against the movement of the ship. Chemical personal protective equipment should be kept ready at the storage site. This will consist of a chemical-resistant face shield, goggles, gloves, and apron. Anyone using chemicals should know where the nearest eye wash station is. There's usually more information on the safety datasheet than on the product label, but labeling is very important. All containers must be properly labeled with appropriate danger symbols and chemical names to ensure the contents are known and the potential risk minimized. Chemicals should never be decanted into containers that might be confused with food or drink containers. If chemicals are decanted to smaller storage vessels, these vessels must also always be clearly labeled. Flammable chemicals are best kept in a fire-protected space. Paints and thinners should be stowed in the designated paint store, where safety datasheets and respirator masks should be available. Any unused paint or thinners should be returned to the paint store after use. The lids should always be closed. Since many chemicals are hazardous to the environment, storage areas normally have some means of containment of spilled chemicals and are not commonly fitted with drains. Similar products should be stowed together. Check the safety datasheet for any reactions with other chemicals. For instance, the boiler chemical on this safety datasheet is an alkali and would react with any acids. Never stow acids and alkalis above or below each other. Chemical containers should be inspected regularly. Leaking or damaged packages should be removed and the contents transferred to a properly labeled new container. It's important that an inventory is kept of the chemicals on board, so that in the event of a fire or other emergency, the risks to those dealing with the emergency are fully understood. Any spillages should be cleaned up. And any waste transferred to suitable sealed and labeled containers. Unwanted chemicals should be landed ashore as hazardous waste and a receipt obtained. When handling chemicals, the proper PPE must be used. Avoid direct contact with chemicals. Never smell, inhale, or taste a chemical. Wash thoroughly with soap and water as soon as possible after handling any chemical, particularly before eating, smoking, or using the toilet. Guidance on what personal protective equipment is required can be found on the safety datasheet. This will tell you what hand, eye, skin, and respiratory protection you need. In some cases, where and how you use the chemical, for instance, how much ventilation there is, and whether you're liable to be exposed to dust from the chemical, may determine whether you need to use a respirator. Solvents, such as cleaners for electrical parts, have been known to cause deaths at sea. Take your own safety seriously always check the manufacturer's safety data sheet. Always check that you have the correct, approved protective equipment. Make sure you have the right type of gloves and that they're the right size and in good condition. Gloves will not last forever. They often have a limited use period and should be discarded after this time, even if no contamination is obvious. Wear clothing under overalls to reduce contamination. Follow the manufacturer's instructions for laundry and cleaning personal protective equipment and overalls. If these instructions say that cleaning is not possible, dispose of the items if they're dirty or showing signs of contamination. Disposable coveralls should be discarded after each job. Remember those accidents we discussed at the beginning of this training. Always take the time to find out what protective equipment you need and then make sure you wear it. We've already seen that full advice on first aid relating to a chemical is given on the safety data sheet. However, there are some general points that you should keep in mind if you're the first person on the scene. Don't become the next casualty. Try to take in the situation and determine which chemical is involved, given the location of the casualty and any labeling on containers. Any advice given here can only be general. You need to get the safety data sheet and find the advice on first aid. Beware fumes. Do not attempt direct mouth-to-mouth resuscitation if you suspect that acids or poisons may have been ingested by the person. If you find a casualty, you will need help and you must put your own safety first. You'll not help the casualty by becoming the next victim. Raise the alarm and give as much information as possible about the scene, having assessed the situation as best you can without putting yourself in danger. If you feel confident in your assessment, remove the casualty from any imminent danger. In most cases, transfer to fresh air and the removal of any clothing soaked with the chemical are the first actions recommended. For acid burns particularly, prompt and prolonged washing of any burn areas with clean water is recommended, so think about the nearest source of running water. It's worth noting that modern practice, reflected in the advice on safety data sheets, is not to induce vomiting. This has been found to be very ineffective at removing poisons or acids from the body. In fact, it makes things worse, as it can speed up the rate at which the body absorbs poisons. As we have emphasized, you should check the safety data sheet for the correct first aid procedures, but you may have to act quickly and, at first, on your own. The safety data sheet will tell you the correct first aid procedures and will also give you the contact details for expert advice on dealing with the casualty.
Now that we have gone through the risks, storage and handling requirements, and first aid measures for chemicals in the engine room, you should understand the importance of safety data sheets. Make sure that you have a safety data sheet for any chemical that you are using, that you are familiar with what it says, and that you know where to find it in an emergency. We have ended this training with a brief discussion about immediate first aid. But if you treat chemicals in the engine room in accordance with your own ship's procedures and use the information on the safety data sheets, there won't be any accidents to deal with. Chemicals are dangerous, but provided they are stored, handled, and used correctly, the dangers to you, your colleagues, and the environment can be controlled.